Hi, my name is Vadim, and I'm happy to present our paper on one-shot image synthesis. The topic of our work is concerned with generative adversarial networks. Given a sufficiently large dataset for training, current state-of-the-art GANs generate highly realistic image samples. Importantly, these generated images are different from training examples, which means that they can be useful as data augmentation for downstream applications. However, for some applications, it is difficult to collect a large dataset containing thousands of images. Training GANs in such limited domains is challenging due to training instabilities such as memorization and mode collapse. In order to improve application of GANs in practice, in this work we are interested in the following question: how to train a GAN in case of very limited data? We aim to scale GAN models to the extreme case of one-shot image generation, when only one data object is available. Previously, this task was studied in the context of learning from a single image, where the task is to generate diverse samples given as little as one image for training. In this work, we introduce a novel setting of generating images from a single video, where the training data is a collection of frames from a short video clip. In practice, capturing one short video may take as little effort as collecting an image. However, a video contains much more information about the scene and the objects of interest. For example, on a video, objects may appear in different locations and be captured from different views. Therefore, we believe that such data enables generating more interesting scene compositions, for example by combining information seen in different video frames. The main challenge of training GANs in such one-shot scenarios is overfitting to little training data. Particularly, a standard GAN discriminator can simply memorize all the training examples and teach the generator to reproduce them with no diversity. This result is not interesting, as generated data cannot be used as data augmentation. A popular approach to overcome discriminators' overfitting is to employ a patch-based GAN operating at various image scales. However, such models are limited to patch learning and cannot learn high-level semantic properties. So, they often suffer from incoherent shuffling of image patches, which leads to distortions in the appearance of objects or incoherency in global layouts, when, for example, sky textures appear below the horizon line. We introduce an alternative solution to overcome the discriminator overfitting. To achieve this, we design a two-branch discriminator judging image content separately from the scene layout. At each training iteration, a given image is firstly processed by standard ResNet blocks to learn low-level image details, such as colors and textures, and to build an image representation. This representation is next taken by two separate branches. Firstly, the content branch collapses the spatial information via an average pooling operation. The following ResNet blocks have access only to the information about objects encoded in channels, regardless of their spatial location in an image. So, the content branch evaluates what is in the image, but not where. Secondly, the layout branch reduces the learned feature representation to one channel via a simple convolutional layer. Such one-channel map naturally encodes the spatial arrangement of scenes. Having access only to this information, the layout discriminator blocks evaluate the overall realism of scene layouts, but not the appearance of objects in the scene. So, the layout branch evaluates where the objects are, but not how they look like. The final loss of our one-shot GAN discriminator is the sum of losses for each discriminator part: the low-level feature extractor, the content and layout branches. Note that the content and layout branches receive reduced information from the previous layers, which prevents their overfitting. We demonstrate the effectiveness of our two-branch discriminator with the following ablation study. Given a single training image, a model with a standard GAN discriminator without branching memorizes the training image and reproduces it with no diversity. Using only the content branch improves synthesis diversity, but the model fails to produce realistic positioning of objects. On the contrary, using only the layout branch frequently fails to learn correct appearance of objects. Finally, using our full model with both branches leads to diverse and high-quality image generation. To avoid mode collapse and boost the diversity of synthesis further, we propose to add a diversity regularization loss to the training objective. This loss operates in the feature space of the generator. That means, for each generated image, we collect a representation by combining features extracted from intermediate generator layers. Then, the distance between features extracted for different images is maximized, which encourages the generator to produce more different images for different noise vectors. As we show in our experiments, such diversity regularization loss notably improves the diversity of synthesis. We evaluate one-shot GAN in two challenging one-shot data regimes. Firstly, given a single training image, our model is able to produce high-quality and diverse images, varying the content and layouts of scenes. For example, one-shot GAN can generate images with different number or shape of rocks, or change positions and configuration of waves in a sea. For an urban scene, our model is capable of removing pedestrians, side fences, or even hallucinate new car instances on the road. Here we show the ability of one-shot GAN in the introduced setting of a single video. For the generated frames shown below, we demonstrate the respective nearest images from the training videos, as measured by LPIPs. As seen from the figure, one-shot GAN achieves good image quality, at the same time augmenting the original training data with non-trivial transformations, such as duplicating objects, removing objects, changing their shape, or changing the layout of the background. Compared to previous approaches, one-shot GAN generates images of higher quality and diversity. For the training videos shown above, the patch-based model SynGAN, which was tuned to learn from a single image, cannot meaningfully combine information from several video frames, so it is prone to generating images with an incoherent global layout. A few-shot model FastGAN, on the other hand, fails to augment the training frames with non-trivial changes, repeating them or their augmented versions, for example horizontally flipped. On the contrary, one-shot GAN is able to produce coherent images and augment the training set with interesting novel combinations, for example changing the length of a pass or producing a novel jumping obstacle configuration. From both single images and single videos, one-shot GAN sets a new state-of-the-art in image quality as measured by CFIT and in diversity as measured by LPIPs and multiscale SSIM. Only our model successfully learns in both one-shot scenarios, which indicates more universality for various data regimes. Finally, with one-shot GAN, one can achieve more different images compared to the training set, which suggests a potential for data augmentation in limited domains. In summary, in this paper we introduced a novel benchmark of generating images from frames of a single video. We proposed a two-branch discriminator architecture that helps to avoid overfitting in the challenging one-shot regimes, and a diversity regularization loss that ensures high diversity among generated samples. In effect, we state a new state-of-the-art in one-shot image synthesis. Thank you very much for your attention. For more details, please see our paper.